Hello everyone, I am Disha K of CSC Cybersecurity Department. Today I am going to discuss about a develop a C program to simulate the linked file allocation strategies. Introduction. In this presentation, we will explore the development of the C program to simulate the linked file allocation strategies. Linked file allocation is a method used in operating system to manage the file storage. The program will be demonstrate how different linked file allocation strategies work and the impact on a file management. Linked file allocation overview. Linked file allocation uses the pointers to link the data blocks together on the disk. Each file is represented by linked list of data blocks. This method allows for the dynamic file size allocation and efficient use of a disk space. File allocation strategies. The program will be simulate the various linked file allocation strategies such as a contiguous, chained, and indexed allocation. Contiguous allocation stores each file in a contiguous block of a disk space. Chained allocation uses the pointers in each block to link to next block in a file. Contiguous allocation. In a contiguous allocation, the file stored in a disk block. In this, the method allows for a fast access to the file but lead to fragmentation. The program will be demonstrated how contiguous allocation works and its disadvantages and advantages. Contiguous memory allocation in an operating system is a technique where the logical block file is assigned the continuous physical work. Chained allocation. Chained allocation links each block for a file together using a pointers. This method eliminates the fragmentation but can lead to a slower access time. The program will be show how chained allocation is implemented for a file management. Indexed allocation. Indexed allocation use an index block to store the pointers to each data block of a file. The method provides a fast access to the file and reduce the fragmentation. The program will be show how indexed allocation work and its benefits compare the other two strategies. Simulation environment. The C program will develop using the data sets such as a linked list and a pointers. The simulation will allow the user to create, delete and modify the file using the different allocation strategies. User can visualize how files are stored on the disk and track disk space utilization. Simulation environment is defined as a programming environment of a computer that is dedicated to system simulation that takes care of a flexible and intelligent interfacing between the user and the systems. Program implementation. The program will include the function for a file creation, deletion and modification. The different linked file allocation strategies will be implemented as a separate modules. User can select the allocation strategies they want to simulate and observe the results. User interface. The program will be use the friendly interface with options to create, delete and modify the file. The user can input the file name, size and choose the allocation strategies they want to use. The interface will be display the visual representation of a file stored on the disk. Contiguous allocation simulation. The user can simulate the contiguous allocation to observe how files are stored in a contiguous disk block. The program will be demonstrate how contiguous allocation handles the file creation and deletion. The fragmentation issues and a disk space utilization will be visualized during the simulation. Chained allocation simulation. Chained allocation simulation will show how the files are linked together using the pointers. User can create the files of varying size to observe how chained allocation manages the file storage. The program will illustrate the traversal of the linked blocks in a file using the chained allocation. Indexed allocation simulation. Indexed allocation simulation will show the use of an index block to store the file pointers. User can see how the indexed allocation provides a fast access to the file and reduce the fragmentation. The program will be demonstrate how the index block is updated when files are modified or deleted. Performance evaluation. The program will include the performance matrix to evaluate the efficiency of each allocation strategies. The matrices such as access time, disk space utilization, and fragmentation will be measured. The user can compare the performance of the contiguous, chained, and indexed allocation strategies. Advantages of a linked file allocation. Linked file allocation strategies offer a flexibility in managing the file storage. They can accommodate the file of a varying size and reduce the wasted disk space. The program will highlight the advantages of a linked file allocation over the other methods. Limitations of a linked file allocation. Linked file allocation strategies may lead to increased the overhead due to the pointers management. Fragmentation can still occur in a certain scenarios. Implement the disk performance. The program will address the limitations of linked file allocation and potential solutions. Real-world applications. Linked file allocation strategies are commonly used in a modern operating system. The file systems such as NTFS and implement the variations of linked allocation for efficient file management. The program will demonstrate how linked file allocation is applied in a real-world scenarios. Future development. The C program can be expanded to include the additional file allocation strategies and optimization. Integration with the file system utilities and disk management tools can be enhanced with the functionality. The program can also support the visualization tools for a more interactive user experience. Conclusion. The development of the C program to simulate the linked file allocation strategies provide the insight into file management techniques. User can experiment with a different allocation method and understand their impact on a disk performance. The program serves as a valuable education tool for learning about the file allocation in operating systems.